that too dark?
Well, maybe not. First of all, I want to tell you I'm a writer, and COVID really was kind of exciting because Zoom came about, and I could write to my heart's desire and do little PowerPoint things, and it was fun because you did it not live and nobody knew that you were reading from a script. So I really liked reading from a script because that's what I do best, I write, and I'm reading from a script. So all of you just need to watch the beautiful pictures and listen. So tides are one of the most reliable phenomena in the world. As the sun rises in the east and the stars come out at night, we are confident that the ocean waters will regularly rise and fall along our shores. This dramatic introduction is on the NOAA website. Now, I have used it before. I think this dynamic constant is something to hold on to during these topsy-turvy times of stress-filled world news events of wars and our concerns for our drought-stressed lands here at home, and just so much going on with each and every one of us. So NOAA, as I'm sure you know, is the National Oceanic and Atmospheric Administration. It is under the U.S. Department of Commerce. NOAA likes to define things to the nth degree, as I'm fond of saying. And by definition, tides are very long perioded waves that move through the oceans in response to the forces exerted by the moon and sun. Tides originate in the oceans and progress toward the coastlines, where they appear as the regular rise and fall of the sea surface. In addition to tides being affected by the moon, sun, wind, weather, shoreline, and shape of bays and estuaries also come into play. And as you know, the oceans don't work by tides alone. Their sister phenomena are the currents. So the major force that produces the currents is the wind, which causes ocean circulation, which in turn is dominated by geostrophic eddies, specifically cyclones and anticyclones, that are the ocean equivalent of the storms we experience in the atmosphere as weather. Now that's it for the background information, and the rest of the presentation is a lot more colorful. So, I've talked about this before, and perhaps this slide is familiar to you. The more turbulent the weather, the more action in the ocean. The more action in the ocean, the better the pickings on the beach, and that's the thrill of beachcombing. Those submesoscale fronts are most energetic close to the ocean surface, thereby making that same activity that gives us beachcombers so much delight instead turns deadly when certain creatures suffer the same fate as shells and sea beans tossed ashore like so much debris. Sea creatures stranded and left to die, that combination of strong currents, severe winds, dramatic weather systems like hurricanes, and even regular events like the full moon, where the pull of the full moon exacerbates strong currents. And now the turbulence and the strong seas are the miscreants rather than the benefactors. The ocean activity this presentation focuses on is the intertidal zone and some of the creatures we might come across at different times of the year. NOAA defines the intertidal zone as the area where the ocean meets the land between high and low tides. There are 4 physical divisions, each with distinct characteristics and ecological differences. They are spray zone, dampened by ocean spray and high waves, and is submerged only during the high tides or severe storms. The coast off the state of Maine comes to mind. High intertidal zone floods during the peaks of daily high tides, but remains dry for long stretches between high tides. It is inhabited by hard sea life that can withstand pounding waves, such as barnacles, marine snails, mussels, limpets, shore crabs, and hermit crabs. Middle intertidal zone, over which the tides ebb and flow twice a day, and which is inhabited by a greater variety of both plants and animals, including sea stars and anemones. Low intertidal zone, virtually always underwater except during the lowest of spring tides. Life is more abundant here because of the protection provided by the water. With those definitions, the middle intertidal zone describes the geography of our South Padre Island beaches and the beaches of Isla Blanca and Boca Chica. Oh, I'm glad you're here, Tony. Most of the creatures we come across on sand are jellyfish because many jellyfish swim close to the ocean's surface, which makes them more vulnerable to the whims of the weather, which is also why at certain times of the year, spring and summer, sea stars and sand dollars are passively brought to the shore, but that's a topic for another day, perhaps.
Tell them what that really is.
Well, wait. Jellyfish do not have strongly defined muscles, nor do they have brains as developed as those of fish and other types of marine life. While fish can swim away from ocean currents caused by storms, most jellyfish aren't powerful enough. I've included the dates that I've photographed, the sea life that I found on the beach, so you can be sure to go to the beach during those months if you're so inclined to see some fascinating objects. I'm beginning with this photo because it was the most difficult to identify, and in the end, it still may not be correct, but this is possibly a cannonball jellyfish. I, naturalist, my favorite go-to for identifications, liked this as the southern moon jellyfish first, then two species that would probably never make it to our Gulf shores, and a fourth possibility called it the cannonball jellyfish. The trouble is that a southern moon jelly probably would not be as defined as the specimen in this photo, nor is milky white. They tend to be flatter on the beach, more like an ill-defined blob, and more clear than whitish. I want to call your attention to the link at the bottom right of this slide because if you aren't already familiar with it, it is a really fascinating Texas A&M marine species website. So, information here differed in the identification of the species and left me rather confused. Whenever I cannot get a definitive ID on something, I go to our local expert, Tony Reisinger, the Cameron County Extension Agent Extraordinaire for Coastal and Marine Resources with Texas Sea Grant at Texas A&M University and the Texas AgriLife Extension Service. And if he doesn't know, he will know who to ask. So Tony has seen both cannonball jellyfish and southern moon jellies on our beaches. The southern moon jellies, he agreed, have a less defined ball shape when beached. And Tony and I discussed these things over the telephone recently and came to the conclusion, and perhaps I watched too many murder mystery programs on TV, but just maybe it was a body part implant that somehow...
Oh my gosh.
That somehow...
Oh, that's hilarious.
washed ashore from someone murdered at sea. However, it was about 6 to 8 inches in diameter.
Wow.
As you see, I photographed this in 2008. It is the only photograph I have of it and anything like it because I've never seen another one. And 2008 was 2 years long before I knew about Texas Master Naturalist. I didn't know I needed to be well-versed in forensic for accurate identification photography. I know better now. Anyway, one clue, if you were to look straight down on a cannonball jelly, is to look for 4 oblong circles in a sort of 4-leaf clover design. The angle of my primitive photo does not show that. So cannonball jellyfish are very white as opposed to clear-looking. They have a bell that is rounded, ball-shaped, translucent, rigid, gelatinous, and whitish or milky, according to the Texas A&M site that's on the bottom right corner. Sometimes the bottom of a cannonball jellyfish bell found in the Gulf is rimmed in brown pigment. This is not. There is a rigid stalk that extends from beneath the bell. Attached to the end of the stalk is a cluster of finger-like oral arms surrounding a mouth. They have no tentacles. There are no other local species with that rigid, rounded bell like a cannonball jellyfish. Cannonball jellyfish are found in the Gulf and Bay. They float near the surface. Also called cabbage head and jelly ball, they can be about 10 inches in diameter. Although they have no tentacles, they have stinging cells inside the bell. The sting is very mild, according to the website, so trust that, if you will. So these creatures can swim very fast, which is in contrast to what I said earlier. Most jellyfish are at the mercy of the wind and waves, but the cannonball uses its oral arms to swim. It is a strong horizontal and directional swimmer as a mature adult, but they also cannot swim against the current. They are usually found beached in summer and fall. They have a lifespan of about 3 to 6 months. Cannonball jellyfish are carnivores and feed on fish eggs, planktonic larvae of mollusks and snails, zooplankton, and red drum larvae. One of the main predators is the endangered species, leatherback sea turtle. Colder water temperature, coastal currents, and onshore winds can all play a role in washing cannonball jellies onto Texas local beaches. They are most abundant in coastal waters of the southeastern U.S. and the Gulf of Mexico, and they can group together in large numbers. The southern southern moon jelly, on the other hand, can get up to 12 inches in diameter, although jellies are known by their ability to sting using harpoon-like cells on their tentacles to force toxin into their prey. The moon jelly possesses little danger to humans. They lack the long, potent, stinging tentacles of many jellyfish and instead have hundreds of short, fine tentacles that line the bell margin. The moon jelly's sting is mild, and most people have only a slight reaction to it, if anything at all, according to the South Carolina Aquarium website, so trust that, if you will. Southern moon jellies eat tiny zooplankton, mollusk larvae, crustaceans and small fishes, fish eggs and larvae, and cladocerans, which are water fleas. So seabirds, sea turtles, marine mammals, and fish like ocean sunfish eat moon jellies, and in the Southeast Asian countries, they are eaten by humans. Jellies can be found in aggregations of thousands of individuals, and for those of you interested in collective nouns, that grouping is called a smack of jellyfish. So summer is when jellyfish reproduce and storms are more prevalent, which adds to the proclivity of finding beached creatures. Jellyfish, like an Atlantic sea nettle, which I found near the end of March and again on May 5th in 2022, pictured in this slide, have a weak internal pumping mechanism that allows them to float, but they cannot steer away from danger. When they are caught in a strong current, they have no means of escape, making them susceptible to washing ashore. And although fascinating to some of us humans, it's death to the stranded ocean creatures that are washed ashore. A small number of jellyfish are pushed ashore by the regular changing of the tides, and sometimes hundreds of jellyfish are beached as a result of unusual tidal activity. Adult jellyfish drift in the water with limited control over horizontal movement, spending their days drifting through the ocean, letting themselves be carried wherever the wind takes them. By the same token, many marine specialists agree that washing ashore is part of the natural life cycle of jellyfish, and that may be so, but it sometimes presents a dilemma. And here's the dilemma. Many people want to rescue beached sea critters. I know, I'm always in a quandary about that. On the one hand, being a water baby myself, I'm always tempted to get the poor thing back in the water. But I also know that I wouldn't be able to toss it far enough to keep it from the wave action that would bring it right back to the sand. And I'm sure others feel that same way about rescuing creatures in need. So I want to address this human ethical dilemma right up front, so you all stop feeling guilty about not rescuing sea life stranded on the beach. According to research, marine specialists say that once most creatures hit the beach, it's already too late. For instance, jellyfish are 98% water. When they wash up on shore, they quickly dehydrate and die. Even if they are tossed back into the intertidal zone waters, chances are they cannot fight against the surf action that washed them ashore to begin with. As I have speculated, they are more than likely to be redeposited right back on the stand. Not to mention the dangers of attempting a rescue. Some jellyfish have powerful, painful, deadly stings. So, in the photo on the left of our pretty Atlantic sea nettle, we can marvel at the symmetrical design of the gelatinous bowl-shaped object that in the photo on the right, check out those pretty but painful cinnamon-colored tentacles trailing on the sand that are well hidden in the photo of the one taken in May on the left. In the Atlantic sea nettle species of jellyfish, although the toxin is mild, the sting is painful and can cause severe reactions in people sensitive to its sting. And how does one know if they have a sensitivity? Yeah, it's called original research, I think.
Yeah.
So most jellyfish prefer the high salinity of the ocean, which is 35 parts salt to 1,000 parts water, as their habitat. Jellyfish have a transparent, gelatinous body and an umbrella-shaped bell called a medusa. Tentacles with stinging cells hang from the bell. The stinging cells are called nematocysts. So the Atlantic sea nettle inhabits the Atlantic coast of the United States I am ahead of myself, but that's all right, I'll catch up, as well as the Gulf of Mexico. It is smaller than the Pacific sea nettle and has more variable coloration. Ours are typically pale pinkish, possibly yellowish, often with radiating, more deeply colored stripes on the ex-umbrella, especially near the margin, and this is where I'm supposed to put this slide up. The ex-umbrella is labeled in the red box in this diagram, and I found it on the internet by PLOS1 for credit there. It's not my photo. The sea nettle is radically symmetrical, marine, and carnivorous. It has tentacles that surround the mouth to capture food. Sea nettles have no excretory or respiratory organs. Each sea nettle is either in a free swimming stage or a polyp stage. The free swimming stage, or medusa, reproduces sexually, and the polyp stage reproduces asexually. The Atlantic sea nettle is a bell-shaped invertebrate, usually semi-transparent and with small white dots and reddish-brown stripes. They are mostly translucent with symmetrically placed brownish patterns on the body that can relatively easily be seen on the sand. They are particularly abundant near the surface in coastal waters. The sea nettle's sting is rated from moderate to severe and can be noxious to smaller prey. It is not, however, potent enough to cause human death, except, of course, by allergic reaction. Stinging sea nettles are carnivorous. They generally feed on zooplankton, ctenophores, other jellies, and sometimes crustaceans. Sea nettles immobilize and obtain their prey using their stinging tentacles. Sea nettles are also able to consume minnows, bay, anchovy eggs, worms, and mosquito larvae. The defense mechanism of the sea nettle reduces the amount of natural predators, but they are prey to mainly sea turtles, ocean sunfish, and larger jellyfish. That was a lot of information, and the rest of the critters don't have nearly that much, so wake up.
Oh.
All right. So, no, it's not what you think. Water jelly is a lined water jellyfish, is a type of crystal jellyfish, but is not a true jellyfish. It's actually a hydroid found in the Gulf and oceans. It looks like a disc, but it's a gelatinous bell, bowl-shaped, broader than deep, no color to speak of, translucent to transparent. It has radiating canals that feel like ridges. I did not touch it, so I'm relying on my favorite website to be correct about the ridges. Rows of wart-like bumps are on the underside of the bell. The center of the bell has a circular area which is smooth with no ridges. It has tentacles that are very fine and small and do not sting. Water jellies swim by pulsing their bell to push themselves through the water, but they're not strong swimmers. They can swim up and float down. To keep themselves off the beach, they tend to normally keep themselves about 6 feet away from the surface of the water. One theory is that finding one on the beach, it was probably dead before it was washed ashore. Hydrozoa are carnivorous, feeding mostly on small crustaceans, fish, eggs, and other larvae. Even though they reportedly do not sting, many beach finds of the gelatinous sort are better with being photographed and not handled and left for the next beachcomber that comes along to ponder. One of the reasons we see flocks of beach jellyfish every summer is because they float with a rigid sail that pokes out of the water. The Portuguese man-of-war superficially resembles a jellyfish, but is actually a siphonophore. Okay? That wasn't easy. The float can be up to 6 inches tall. They cannot swim and are completely propelled by wind-initiated ocean currents. While this often helps them travel and snag food, the float is vulnerable to the wind, which will sometimes blow full colonies ashore. They can float in groups of more than 1,000. Whether conditions are to blame for widespread jellyfish destruction, there's nothing that we as humans or the jellyfish can do to avoid this inevitable fate. Jellyfish generally beach themselves on accident due to storms, the current, or wind. And as I mentioned earlier, jellyfish contain high amounts of water, so when they wash up on shore, they dry out and die incredibly quickly. They don't survive for very long, but their tentacles can still sting even after they've died, so you'll want to avoid stepping on their corpses. The Portuguese man-of-war is a great example of this. This specimen was found toward the end of April, and they are common occasional finds through the spring and summer. Portuguese man-of-war is a highly venomous open ocean predator, and as I mentioned, specifically resembles jellyfish, but is actually a cyanophore. Each man-of-war is actually a colony of several small individual organisms that each have a specialized job and are so closely intertwined that they cannot survive alone. The float is partially filled with carbon monoxide. So the float keeps the colony at the sea surface. The feeding tentacles, which may be 160 feet long, are covered with stinging cells that can deliver a powerful sting that paralyzes its prey. Portuguese man-of-war eats small fishes, shrimp, and pelagic crustaceans and other invertebrates and small animals in the plankton. In turn, they are eaten by loggerhead sea turtle, octopi, sea slugs, ocean sunfish, and crabs. Some animals, like the common clownfish, have some immunity to stings and may feed among the tentacles. The violet sea snail, Janintha, prey on Portuguese man-of-war. Sea slugs in the genus Glaucus also eat man-of-war and repurpose the stinging cells for their own defense, like the blue dragon sea slug, which is found throughout the Atlantic, Pacific, and Indian Oceans in tropical and subtropical waters. Touching a Glaucus can pack the same wallop as touching a man-of-war. Linda McGonigal gave a great presentation on the blue dragon last year. I've not come across the violet sea snail, but you can be sure I'll start looking. They are unique, according to a paper by the curator at the Houston Museum of Natural Science. Violet or purple sea snails can be found in every warm water sea or ocean around the world. In years past, these beautiful and unusual mollusks were plentiful and were easily found in great numbers on Texas beaches, along with their man-of-war host, after being washed ashore in certain times of the year. As the number of man-of-war has declined in numbers, so also has the number of Janthina. Though both can still be found on local beaches, their reduced numbers make it rare and a special find, according to that article. So blue button, porpita, usually live well out to sea on the surface of the ocean. They look like a jellyfish and sting like a jellyfish, but they are not a jellyfish. They are a colony of many small animals known as hydrozoan polyps. They are a distant cousin of Portuguese man-of-war. Their closest relatives are sea sails, also called by-the-wind sailors, like the top right image. It's not my finger there, nor my photo. But blue buttons are passive drifters and lack any form of propulsion. They wander the ocean at the pleasure of the wind, the waves, and the current. The blue button is a part of the neustonic food web, which covers the organisms that inhabit the region on or near the surface of the ocean. On the open seas, they can propagate in the hundreds. They eat small plankton and larval crustaceans, and in turn are a food source for the blue sea dragon sea slug, the bottom right photo, which also was taken from the internet. The blue jellies follow their food, and eddies and currents wash them ashore. As the summer sun warms the Gulf of Mexico, plankton bloom and saturate our shallow coastal waters, and blue buttons are drawn to shorelines by the plankton blooms, which is their source of food. The round disc, typically about 1.5 inches in diameter, is filled with gas, which creates buoyancy. Trailing underneath the disc are numerous tentacles like strands of hydroids. At the ends of the tentacles are powerful stinging cells called nematocysts. Inside each cell is a coiled harpoon-like spear that is launched when water pressure enters the cell. These spears are used to deter predators and to capture prey such as crab larvae. The blue button isn't deadly to humans, experts say, but the stinging ends of its tentacles can cause skin irritation. The float organ is responsible for the organism's vertical movement and also contains pores that are able to communicate with other porpita organisms as well as its surroundings. The hydroid colony polyps can range from bright blue, turquoise to yellow. The polyps resemble the tentacles of jellyfish. It is preyed upon by the sea slug, violet sea snails, the blue dragon, sea turtles, and seabirds. Porpita will hunt active crustaceans like crab and fish. In July this year, Tony Reisinger, an agent with Cameron County Marine Extension, was quoted in the Houston Chronicle saying, "Blue buttons along with Portuguese man of war are washing ashore in large numbers." So remember that. July is a good time to find lots of things on the beach. And we're nearing the end. On May this year at Isla Blanca Beach, I found a good many little pink discs, a bit larger than a quarter, and they were identified as sea pansies, which are related to sea jellies. Sea pansies are a type of soft coral. Soft coral, like sea fingers and sea whips, are soft and bendable and often resemble plants or trees. These corals do not have stony skeletons and are not reef-building corals. Instead, they grow wood-like cores and fleshy rinds for protection. Unlike the blue button that lives on top of the water, sea pansies live on the ocean floor and are anchored into the sand or mud by the peduncle. Even if uprooted by rough seas, the peduncle can establish a new mooring once it settles back onto the sand. They also can often be found living intertidally, completely buried in the sand. A sea pansy is a colony of polyps. Their shape is similar to a lily pad, according to Texas marine species. And the rachis, the body, is flattened but fleshy and has a single polyp which forms an anchoring stem on the underside, which anchors it into the sand or mud. They are generally reddish to reddish purple to deep purple. And this particular species is the only sea pansy in the Gulf of Mexico, and it spends its time on the sandy bottoms. On April 28th, on Boca Chica Beach, we found quite a few mottled sea hare. It was really hard not to consider tossing these lovely creatures back into the sea. I had no idea what they were. I'd never seen anything like them. As with most things I find, I relied on iNaturalist.org on my phone app to tell me what they were. Sea hare are gastropods. They have no outer shell. Their body is globular, soft, and bulky. According to the description at the Texas Marine Species website, the color varies from light brown to dark red-brown or red-purple to lighter color mottling on the head, neck, and wings. And yes, they have wings of sorts. They have wing-like flaps called parapodia, on the sides of their body, attaching behind the rhinophores, which are near the head and join posteriorly. Two broad wing-like flaps are folded over the back. When the flaps are open, there's no groove on the flaps. Their parapodia are undulated in a way that gracefully propels sea hare through the water. Shortly after I photographed the sea hares on Boca Chica on April 28th, you may recall seeing on May 12th, Pan Bradley posted onto our Shell Club Facebook page Leanne Serrani Thomas's great video taken on May 11th, where she had filmed a sea hare in the shallows and swimming, using its wings to locomote. It was quite something to see, and her filming was excellent. She must have been thrilled to capture that footage, and the wing, or rather parapodia, action was much like the folklorico dancers' costumes when they ripple and swirl their long ruffled tiered skirts in traditional dance movements. And the link, if you want to take a picture of that, or I can pass this around later, but that's the link on our Facebook page that you could see the undulation of the sea hare swimming. The head of the sea hare has two rounded tentacles, smaller rhinophores, and rhinophores are scent or taste receptors. They're also known as chemosensory organs on the dorsal surface of the head, and they are tentacle-like sensory receptors behind oral tentacles on the neck. Interestingly, rhinophores allow sea slugs to detect chemicals in the water, similar to a sense of smell. They are used to find food and detect predators, and perhaps used for distance response to water currents. The sea hare's tail is short and rounded. They have a flap, the mantle, on their back that covers their gills and internal organs. Inside the mantle is the ink gland. It secretes purple ink into the water like squid when disturbed. The creatures eat the seaweed, so when waves uproot vegetation and blow it ashore, animals inhabiting the stems and leaves come with them. They also feed on aquatic plants and algae in shallow water. Normally, sea hares occur in waters less than 65 feet, but sometimes they go deeper. Sea hare is the common name for the large group of herbivorous sea slugs. They're cosmopolitan in that they are found in temperate and tropical seas, inhabiting calm, shallow coastal seas and sheltered bays wherever there is an abundance of algae. Witnessing large numbers of sea hare ashore is fairly typical and shouldn't concern us, although it kind of breaks your heart. The stranding is typically from weather conditions, which include days of strong winds and rough surf conditions. And if you remember last spring, we kind of had that. The last creature in this presentation is a sea walnut, which is a comb jelly. And this one was found on the beach on June 23rd this year. As you can imagine, I nearly missed it. But when you're in serious beachcombing mode, you pick up nuances like this colorless, less than 1 inch rise of semi-camouflage blotch of sand-speckled gel. So beached, it looks nothing like a filled-out sea walnut freely floating in the water. And the difference is amazing. So I looked on the internet. And
those are cool.
I know, isn't that weird?
Wow.
So the sea walnut is a transparent or white gelatinous planktonic marine invertebrate, up to 4.5 inches in length. Its habitat is the Gulf and Bay. Planktonic ctenophores, called comb jellies or sea walnuts. Planktonic is a lifestyle. It's organisms unable to swim against a current. They are drifters, passively floating, carried by tides and currents, floating in the ocean, rather than living on the sea floor. For all their gentle, free-floating, laissez-faire lifestyle, sea walnuts are carnivorous predators. They have a broad-based diet of zooplankton, including eggs and larvae, forms of various invertebrates and fishes, barnacle larvae, tiny crustaceans, juvenile fish, copepods, sea jellies, and even some ctenophores. Their predators, on the other hand, include fish, sea turtles, crustaceans, birds, jellyfish, and larger cone jellies, and they are eaten by humans. An article in Genetic Literacy Project calls cone jellies surreal creatures with fragile bodies, often lined with striking bioluminescent lines. Like most cone jellies, the sea walnut is able to emit light by chemical reactions when stimulated in the dark. However, it is caused by a refracted light and not actual bioluminescence, and as a result, can only be observed when an external light source reaches the animal. As the common name suggests, sea walnuts are shaped like the meat of a walnut. 4 deep furrows run from the top to bottom of the animal. As adults, they do not sting. Instead, their tentacles possess special adhesive cells called coloblasts that release a sticky mucus-like substance to trap prey. And that's all I have. Thank you.
Where did you find the cannonball? You didn't say where you found it.
It was 2008, and it wasn't, I don't know. It was, Morgan may remember, it was the first beach trip we took when we moved to Texas.
I might remember.
Okay,
Come on,
so we used to go all the way out to one of those pay for parking places that had bathrooms.
That's important.
And just walk along the beach. So it had to have been
County Beach Access 5.
what?
County Beach Access 5.
Or the
Outdoor.
town. The
Or in
town.
Wait.
Yeah.
Oh, South Padre Island, north.
North, you
Past
mean
the town.
County
Yeah,
Beach
County
Access.
Beach Access.
Yes.
Okay.
Yeah. Thank you.
And you said it was 8 inches?
It was a good 6 to 8 inches. Well, I think it was about this big.
Okay.
Is that 6 to 8 inches?
Yeah, that's big.
It was.
Because I seen something similar to that on Boca Chica Bay, though. It was down
Yeah,
the
they're in the
bay.
bays.
It was in the bay.
I don't think it was a bay because we didn't. It wasn't Boca Chica because we didn't know about it then.
But I have seen them in Boca Chica Bay.
And we didn't know about Isla Blanca, so it had to be the beach access.
As a matter of fact, there was something else similar to that on the beach that day that I was over there on the bay. And back then, this is 20 years ago, I picked up everything, touched everything. And I picked it up, and somebody that was with me said, yeah, you can pick that up, look on the underside. And it filled my hand, but on the underside it was the baby's ear that was encompassed in that big mass.
A baby's ear?
A baby's ear is in
Wow.
a big mass in the bay.
What do
But
you-
why it was up, I don't know. She
I don't know,
said,
maybe the baby's ear was just under it when it washed ashore. It was,
no,
it's
it
on
was
the
like
beach.
attached to the baby's
Oh,
ear.
it was a
wow.
shape
And
of a baby's ear.
Yes, it
Oh,
was the
wasn't a
baby's
real
ear.
baby's ear.
And
No,
you
I know
can-
the shell baby's ear.
And you can get rid of it. I mean, and it's like a live baby ear under there.
Wow.
You know, honestly, that website is really phenomenal if you go to it because it's got like 20 different categories, and like I think most of these were invertebrates probably section, but it's got coral, it's got a ton. It might because it's got tons of pictures also.
But I always thought the baby ear, I've learned later, that they were deep in the sand, so I don't know how it got to the top. But
man.
it did.
I don't know.
Because they're buried in the sand on the bay. They're buried way down in. So I don't know how, unless there was a big storm that really tore the beach up or something.
That's the best time to go on the beach.
Yeah, those sea hares, I remember on Turtle Patrol this last year, I mean, they were covered. They were covered
Which,
all
the sea
over.
hare?
Yeah.
Yeah.
They were like solid, massive,
Has any-
distribution all the way to the Port Mansfield jetties.
Man.
Has anybody else ever gotten a live baby's ear?
No.
It
I've
looks
never
like a
heard of
baby.
it.
You've never heard of it?
Yeah, I had a lot of them. I found a lot of them the day that we had the field trip for the South Texas chapter, border chapter.
Is it a sea creature?
Yes.
It's a shell.
It's a
It's a
univalve,
shell.
yeah.
Yeah, it's a
Yeah.
It's a
univalve.
snail.
Oh,
It's kind of
oh,
flat,
oh.
and it's shaped like an ear. It's kind
It's
of
shaped
and
like a little
milky
ear.
white.
That's right, you did.
I
Here you
know.
go,
Here
here
you
it
go.
is. Here's my book, y'all can pass it around.
But that's the only time I've ever seen a live one.
I've never gotten a lot.
They're always dead.
But I picked up a lot of them that day.
But it just, it
Oh,
comes
yes.
in the ball that it's in like that is slime. I mean, slime just oozes all over you when you pick it up. It's really slimy.
So last year, there was a lot of, I thought they were cannonball jellies, but there was a lot of them on the beach, maybe up north on ATV, but they looked like that, except they were maybe a little flatter on the top. But then they had all those things around the bottom.
Look like little fingers.
Yeah, but they were big, they were this
Right.
big and they were really hard. 'Cause-
Yeah, we get mass strandings of
So
them.
were they cannonball jellies? I'm
Probably.
assuming they were.
Is a cannonball the same thing as a cabbage head?
Yes.
Yes.
Oh, it is?
Yes.
Okay.
Oh, okay.
Yes, that's right.
Oh, God,
Cabbage
I've
head too.
seen,
And there was a
Millions of
lot of
cabbage
those last
heads.
Yeah,
year.
we get a lot.
In Corpus, when I used to race Hobie catamarans in Corpus Christi Bay or windsurf, they were powerful enough in the waves to knock you off of your sailboard.
Oh my gosh.
Yeah, they're hard, and
Yeah, they're really
when they come at you in the waves, they're strong. I mean, they can knock you off your balance.
They're good to eat too. I've eaten them in Japan.
Wow.
They slice them up like rubber bands. And
Japan,
You're thinking of culinary.
yeah, Asia,
Yeah.
Japan, Asia, they seem like they're the
That's kind of boring.
geographical area where they eat the most, jellyfish.
they wanted to harvest them off Texas, but Parks and Wildlife wouldn't let them do it.
Yeah.
I think off Georgia they do harvest them. They trawl them.
And let me tell you, those sea nettles, those sting like you were stuck with a lit cigarette. They
Did you touch it intentionally?
no, it got on my leg. It was
While
on
you
my
were in
leg.
the
I was in the water.
Oh, man.
And then a
But it was-
lion's mane.
But it was in the intercoastal. It was in the intercoastal.
Huh. They're beautiful.
I was windsurfing.
I just love that. It was just, I couldn't photograph it enough.
Yeah, they are pretty.
Yeah.
We want that.
And they have long tentacles.
That water jelly, I've never seen. That's new to me.
That one right there?
Yeah.
Me either. I've never seen that.
I know, I was just lucky
You were.
the last 2 years. I mean, this is just amazing, and I don't go to the beach nearly as often as I want to.
Have y'all ever, Amy,
I
have y'all
have
ever
not
seen,
seen-
that sea walnut?
No, I haven't seen the
I
sea
haven't
seen
walnut,
that.
the water
I've
jelly,
seen
or the
that stuff over
pansy.
Boca Chica, I don't see it out there on the beach.
I
When we
haven't seen the sea
sing,
pansy
we
either.
catch lots of
How
them.
large is that sea
I bet.
pansy?
Yeah.
Or maybe I've seen it and I didn't know.
That's the thing.
What I
you
was
haven't-
looking at.
You're not aware of it, so now we'll be.
Oh,
aware
I
of
can't
it.
imagine being
And
able
then-
to see it while it's in the water either.
Yeah.
Right, because it'd be under the.
the little
under
by the
sand.
wind sailors, you know, on
Yes.
the picture, it showed the little
Sail.
sail thing, but when you find them on the beach, they're just
dried
like
up.
these little clear, they look like plastic.
Well, when they're dried up.
They're
And they're
Yeah.
like 2 inches.
Yeah,
They-
Aren't they?
A lot of them still have their sail
Wax
on.
paper.
Yeah.
yeah, they
Like wax
find
paper.
Right, they're kind of,
And they dry out clear.
Have you seen them here?
uh-huh.
yeah.
Yeah, lots of them.
Boca
Lots and
Chica
lots.
had
When
Yeah.
you
stranded. See one?
Boca Chica.
When the
Ireland
wind
is
blows
in
real
town.
hard, you see a lot of blue buttons and by the wind sailors that are fresh. And then after a while, give them a week or so, and then you see the by the wind sailors all dried up.
There's a lot of them.
Right there.
The top thing,
Yeah.
see that finger?
Yeah.
Look
It
how
turns
tiny.
all clear.
So you
and
don't
the
see it,
blues
the
off
blue.
of it.
Those are the by the wind sailor and then the blue dragons. Have you ever seen a blue dragon here?
She saw one.
So Blue Dragon was over at Boca Chica Beach, and Beth De La Garza, I used her photograph that she had, and then the only other sighting was 2 times at Port Aransas.
Wow.
And you do not want to
come
touch
near.
them.
Oh, no, no,
Whatsoever.
no. I only get as close as the lens allows.
They're beautiful though.
They feed off of the toxin off of the Portuguese man-o-war, but they store all that toxin in the fringes of those finger-like, tentacle things.
They reuse.
Yeah, and they are immune. They have a special kind of chemistry that they're immune to that. But what happens is when they store it, it becomes even more concentrated, like 1,000 times more toxic than the Portuguese man-o-war. I mean, somebody could actually die from one of those.
Man.
And they
so
grow
pretty.
up to 4.5 inches long in Asia. And the one that we had here and in Port Aransas, it was only about an inch long. But even just the inch long one, it was like, could be deadly.
Any more questions?
That was great, Anita, thank you.
Great presentation.